That was actually the one.
Has this flickered yet, by the way? Has anybody noticed? All right, because it was doing something funky. Huh? Oh, this the screen. It's up for 200. That's the Python book for 200. All right. Do I have it? I can already tell my posture is going to be a problem. Oh, yeah.
You got your seat back.
I know. I like this seat. Well, my posture's still going to suck. I'm already slouching. Huh?
Is there someone in the other room or there's just no one in here?
There's nobody in here because that class ended after week 8. The class that was in here.
We can be in here now.
I think so.
We're in 29.
Is that good or bad? Is it good or bad that you can be in here?
Well,
If you don't like the chairs, you can grab good chairs from the lab down there and just wheel them down here. I usually have decent ones. All right. So let's. It's already restarted. All right. So your question was about variables, right?
Correct.
And so let's just kind of go through it this way.
In my work experience with just a procedural language, you just declare a variable and then you have that instance of the variable and off you go. And like the language after, or like with Python, but like in Java, if you're doing primitives, you just do that. Yeah, a primitive works like that in Java. But when you're doing, say, a linked list of string, you say linked list string some variable name equals new.
Like this?
Correct.
Okay. If I were to print out R, what's the output going to be there?
Is it going to be the memory location?
It's going to be a memory address. If I'm going to print out A, what's it going to be?
It's going to have a 5.
It's going to be a 5. This is a variable name. This is a variable type. This is a variable name. This is a variable type. We put a value into this bucket. This bucket is built for holding ints. So what do we put in there? We put in an int. We put a value into this variable. And the value for an object is a memory address, which points to where that object is in memory. So the new keyword says, this is the constructor. It says, constructor, go to memory at the location I'm going to find for you, build me a random object, and let me know where that guy lives. So there isn't a difference between them. This is the type, the variable name, and then the value. The value of R here is a memory address. The value of A here is an int.
Okay, so this explains what happened. So when I was doing my itinerary part of the homework, I did it wrong first.
Okay.
So what I tried to do is I thought, well, I don't want to be popping things off in my main stack, so I'll just make a copy of it. But I didn't make a copy, I just put a pointer at my original stack. So like when I would go through my itinerary, I was trying to
yeah. You were pointing to the same exact thing.
Yeah, I like said, okay, I'm gonna.
You had two variables that went to the same place.
Exactly. I was like, I'm gonna instantiate a new stack, and I was like, all right, you point it to the stack over here, and then I was popping stuff off so I could put it in my itinerary, and it would be like, hey, my stack is completely empty. And I realized, oh, they're just pointers going to the same location.
All right. So this makes sense now?
Yeah, it does actually.
All right. You have in your calendar for 8 a.m. to 8 p.m. this Saturday. Meeting here in computer science department. And he's your boss.
Is there like an object super type then inside?
Yeah, it's called object.
Okay, literally called object.
Yep. If you, here we'll just look at it from a lesson perspective. Let's just choose array adapter. So this is here. So array adapter is very much an Android thing, right? And that guy is a base adapter, which is a java.lang.object.
Okay. What about?
If I click on java.lang.object, you'll see that this guy is the top of the line. He doesn't come from anybody. He's the base. It's how object-oriented languages are built. They all require a top-level object that represents the most generic thing that actually is an object.
So part of the reason I had bad time management is I was trying to understand stuff, and so I tried to make my own linked list object, and I tried to make it generic.
Yeah.
using generics, and so people were talking about using objects or generics. So what's the difference between the type and the object? So like you have inside of the
Well, generics is that angle bracket type.
Angle brackets T.
Yeah, this guy. You mean so if you're going to write your own to support that?
Well, yeah, basically I was copying like what they were doing, but I was like, it's good exercise to me just.
Yeah. So what's your question?
So like some people like when I was looking on Stack Exchange and people were like, okay, here's how I implemented a single link list. Like,
I know what you're asking. You're asking this.
Correct.
So the difference between saying I want a linked list of, let's just say, strings, versus you have your own linked list. So linked list, and this guy is actually a linked list of object types, where you can now store anything that is an object.
Would I be out primitives though?
You would, no, not officially, because in Java and java.lang, there's actually object types for every one of the primitive types. So there's an integer object type, there's a character object type, there's a byte object type. Why do you think there's object types for all of the primitive types?
No idea.
Huh? Well, I've definitely talked about it before.
I definitely forgot.
So my question here is why are there object types for all of the primitive types? And let me just show you real quick in here. I'll just go to.
Do the primitives have methods built into them, or do you need an object to have a method on it?
Well, actually, that's you're right where I want you to be. What's a primitive type? If you had to define a primitive type.
It's like the most basic variable type in any programming language, which is char, int, maybe float, double, that sort of thing.
All they can do is hold a value. That's it. So our examples in Java would be byte, short, int, long, char, boolean, float, double. So those are our primitive types in Java. It's the same for C++, except instead of boolean, it's bool, all uppercase. As well, same. Actually, in C, there is not a boolean. In C, it's just an int you use for true or false. There isn't a boolean official type. Under the hood, it's actually implemented as an int anyways. C#, it's bool, all lowercase. So changes a little bit with the boolean things, but otherwise they all come from C and C++. All of these guys, they're only capable of holding a value. This is a 8-bit signed integer. This is a 16-bit signed integer. This is a 32-bit signed integer. This is a 64-bit signed integer. This is a 16-bit unsigned integer because it holds the Unicode character set 0 to 65,535 for the 65,536 unique characters. This, in modern languages, is held as a constant, true or false, but in older languages, it was represented as a 0 or a 1. Floats are 32-bit before decimal point, 16 after. Doubles are 64 before decimal point, 32 bits after, so 96 total. But punchline, you should obviously have all that memorized now.
Since we're having a nerdy discussion, are they little Indian or big Indian?
Huh?
Little Indian or big Indian?
Well, that actually has to do with how they're stored under the hood, and that's going to deal with the implementation of Java Virtual Machine would probably be big Indian, but it's going to deal with the compiler implementation for how it's going to store the crap. But in any case, all these guys can only hold values. That's it. They are not capable of doing magic tricks to themselves. So, cannot perform methods on themselves. They don't have methods. So that would, does it make sense in modern programming that we might want to do things to integers, to do things to chars, to do things to bytes, so on and so forth? So all of those primitive types have built into, and this is actually a really good lesson for learning the difference between static and non-static. So let me go over here to Java SE, Java APIs. Didn't they change Java? Isn't it java.base now? Yeah. It used to be just java.lang. Now it's java.base.lang. Yeah. So, do we need, so if I tell you, here, I don't want to show you too much. If I tell you that built into java.lang, we have a class called integer, all right, that has methods for operating on int primitive types. What kind of methods do you think they are? Class methods or instance methods, and why? So you can't just guess, you have to. Okay, you think they're instance methods? Okay, why do you think they're instance methods? Okay. Anyone want to tell her why she's wrong? I actually really like the explanation you gave, because you gave the exact explanation of why you're wrong. Static means it's a class method. But you actually said the perfect thing. You said we might have many, many, many integers, right? Therefore, you might want to store the number 5 or the number 7 or the number 14. Makes sense to have multiple instances of integers.
Well, I see, but you're going to perform on one instance, you're going to perform static methods on the instance. You're not going to have instances within an instance of that.
I think you're saying the right thing. You're just using the word instance a lot of times. Okay. Here's the punchline. Now, in Maddie's defense, even though I don't want to defend you because you are wrong, I just want to make sure that's clear. Okay. In your defense, you probably, as a person coming up with Java, could have made an argument for what your view on that, because it would have actually made life a little bit more convenient in some of these cases, especially given the origin or oranges. Is that the thing this week with Trump? You couldn't say origin? Yeah, I think he says oranges. Yeah. So given the oranges, I can't even say it wrong. So it was not all the late night things. He couldn't say origins. He couldn't say the word. Oh, they all did. Every one of them. Yeah. But yeah, everybody misspeaks sometimes. He was talking about some policy where he wanted them to go back and review the origins of some investigation or something like that. He couldn't say the word origins. He kept saying oranges over and over. Well, but we all do sometimes, just we don't have a camera pointed at us every 5 seconds. It's the same argument for like professional golfers where, you know, you have these people external to the tournament who call in and say they saw so-and-so like have a rule infraction. Okay. Well, if you're Tiger Woods or Rory McIlroy or some fan, you know, some really popular player where the cameras are always on you, they're going to see every little tiny thing, right? Okay. If you're Joe Nobody, you don't even have live spectators looking at you. You can just kick the ball wherever you want. So it becomes a little unfair. This actually, I mean, that whole controversy came out last year with this a female golfer named Lexi Thompson, a really popular female golfer, number 2 in the world at the time. She had a 5-shot lead. No, she had a 3-shot lead in like a big tournament, a major, with like 2 or 3 holes to go. And they came and found her out in the course. This is on the last day, and said because somebody called in the day based on some infraction she had the day before, she had a 4-stroke penalty. She goes from being 3 up with 3 to play to 1 down with 3 to play for something that nobody would have thought she did it on purpose. It was just some stupid little like marking the ball, and she put it down in a little bit different way than it was originally. I mean, it was a like 9-inch putt. It had made no outcome difference, but made the whole thing about, you know, when you have cameras on you constantly, people are going to pick up on all of our stupid things is what it comes down to. So anyways, the origin. So he originally asked. You see how I could take computer science? So what he originally asked is, does that mean so this slide here was talking about linked lists of object, where was that? Linked list of object types, where I can hold anything that is an object. And you asked, does that mean that now primitives are disqualified? Because an int is not an object. A char is not an object. Okay, but we do have object types for all of those. And actually, I'm going to even further defend Maddie because there's actually defense against what she's saying for the situation where we do want to use it. Okay, but here's the thing. You would only create instances of an object if you needed to hold fields associated with that object as well as perform methods, right? So, for instance, we create instances of string because we want to have string s equals hello, string s2 equals world. We have different values we're storing inside of our string object, right? And then on top of that, we have methods that can operate on those values, like s.length, s.charat, that kind of stuff. We actually do not need the integer class to be able to hold integers because we already have the ability to hold integers through the int primitive type. Okay, so I can say int a equals 5, then integer dot, here, I'll just bring up the example of this guy. So I'll go down to the, so you're already seeing here's double, here's float, here's integer. So the integer class is going to be filled up with a bunch of static methods, a bunch of class methods, because the integer itself, the integer object, is not internally storing an int. Instead, it's providing kind of a factory where you drop an int into it and it performs some action on that int. So you're going to see a lot of these guys. I'm going to kind of scroll past real quick just so I don't have to talk about that up there. So here's like a hash code for a int, or highest 1 bit. So this is dealing with a binary value of it. Yeah, here we have an integer class called an integer method called max, where I say integer since it's static. This is integer.max, and I pass it 2 ints, and it'll spit out the larger of those 2 values. Number of trailing zeros. Oh, yeah, I like this one. We'll use this one. So for instance, I can say integer dot reverse a. And what this dude will return is he's going to return an int that is, we'll take the binary version of 5, reverse the bits. So 5 is, what, 101? Actually, it's a bad example because 101, you reverse the bits. It'll be stored as a 32-bit number, so it's still a good example. So 10, it'll be, 29 zeros followed by 101. So you're going to reverse that, and now you have 101 in the far, so it's going to be 2 billion, close to 2 billion something, some giant number. So we're reversing the bits of it. But notice that this guy has a class method, had static in front of it, so it's owned by the class itself. So we say integer.reverse, and then we have to provide it with the integer, the int, that we want it to operate on, because we already have a way of storing ints. Now, having said that, it is possible to create instances of integers.
And they're wrapping up the primitive already. So
yeah, but I would call this somewhat of a hack, because they're doing this to allow you to wrap an int primitive type, which is not an object, inside of an object shell. And then there's an instance method that allows us to get the int value. So you'll see in here.
You keep saying instance.
Yeah, here's int value.
What?
So,
I think I just learned the secret to the class.
so see this guy right here? So here's a method called int value that returns an int, and notice it's not static. So in this case, I would say, it made it capitalized. I'll just say, was it just int value? I think it was int value. So that guy would boil down to the value 5. Whereas if I were to print out I, that's going to print out a memory
That's
address.
the memory address.
Yeah.
Okay. And that's what I found with like the stack. I was trying to like get my payload from the stack, and it was just giving me memory addresses, and I was like, oh, okay. I gotta make these things strings somehow.
So the idea here would be is if Java was going to stick to their guns and say, we don't need to have integer objects or double objects or float objects or any of the primitive type object versions, we don't need them to hold the underlying value because we already have a way of holding them. Then they would have stuck by their guns and say, you don't need to then have a constructor for these guys at all because you're never going to create an instance of an integer. Instead, you have this single factory called integer that you can toss ints at all day long, and it will do things to those ints and spit them back. One of the methods is called max. I toss 2 ints at it, it throws the larger one back at me. Another one's called min. I toss 2 ints at it, it throws the smaller one back at me. So it operates on int primitive types.
So if I wanted to like use my integer object inside of an integer method, I'd have to like, where it's specing the value, I'd be typing I.int value.
Correct.
So okay.
Yeah. To extract the actual int primitive type from it, to be able to do math with it,
Correct.
You'd have to say the instance
I
name
could just do
I.getInt.
method, a static method, and have it work.
Correct. Correct. Especially since static methods are called by the class name. Instance methods, methods that do not have static on the front of them, are called by the name of an instance. So in this case,
so
I
would not be
is
able
an
to call
instance of the integer class.
So the class method. Okay, I see what you're saying. So I
So-
wouldn't be able to call anything that integer dot could call.
Right. So because I'm calling int value here using an instance of the integer class, if I go to the documentation, I expect to not find the static keyword in front of that guy. Because if it did have a static word in front of it, then I would call it by saying integer dot int value.
That makes sense.
But since I'm calling it with the name of an instance, I go in and look at int value, and this guy does not have static in front of it.
So it's
If-
an instance. So how is that wrong?
I mean, how are you wrong?
Did I assume that's the instance?
Well, notice that most of these methods have static in front of them. And
You haven't answered that question.
yes, I did.
You were just talking
I
about
just said a factory. It's like a factory.
Yeah,
All right,
you're
all right,
saying
all right.
instant.
All right, all right.
So what he's saying is that integer.
We paid. we.
It's like a half singleton, half object. It's weird.
This is weird.
No, this thing here, the fact that this method here exists, I'm gonna highlight 2 things. That guy right there, this int value, and up here in the constructors.
Wait, okay.
No, no,
Okay.
Quran. All right, hold on. Let me just say the other part. I'm gonna go up to the constructors for this guy. Yeah, actually, look at this. Constructors, it's now deprecated. It's rarely appropriate to use this constructor. But they did create a constructor for integer that takes an int value as a parameter with the sole purpose of being able to wrap an int primitive type inside of an integer wrapper, which then allows you to pass that int around as an object. So if you wanted to have a linked list of object types, you can technically put anything that is an object. And if I look up here at the top of integer, notice here that integer is a number, which is an object. So if I had a linked list of generic objects, I could hold integers in there. Okay, so really the only thing that's in this class that is not static is int value to extract the int primitive from it, and then this deprecated constructor that I think it's been deprecated forever, but basically this thing, deprecated usually means this is going away eventually. So I don't know how they're going to replace it. They might actually, to be honest, they might even unprimitive ints and make you always represent the int primitive type as an object.
It actually makes sense now that I think about it, because you do integer dot parseInt, which would not be an integer.
Well, right, but that's for operating on strings. That one's a little bit different, but
But you're calling
I guess it's similar.
integer.
it's a string representation of a number.
No, but she's right, because it's a method that you have to say integer dot. You can't say instance do this,
Well, right, because it's a static method.
Yeah.
Well, that's what I'm saying. So.
But that particular method's not operating on ints.
No, I understand.
That particular method's operating on a string representation of a number which we presume is an int. So that it's, I mean, you're 100% right. It's just not the best example of this guy kind of advertised like the integer class kind of being like a factory. And he exists one time. We don't have instances of this guy. It's one big factory that I can throw ints at, and he does things with them. I toss 2 ints, he throws me the larger one back. I toss 2 ints, he throws me the smaller one back. I toss a string at him, which represents a number. He spits back the int version of that number. Something like that. All right, so this kind of comes full circle. Primitive types are not off the table as long as we're willing to wrap them inside of our object type version for them.
It makes sense because some people are like, oh, just use the object type, and other people are like, use the generics. But now, to finish my question, then we can get back to our regular scheduled teaching.
Why generics? Why generics versus
generics? Don't care. You can use it.
Well, but I'll show you the advantage. It's really a convenience thing.
Okay.
So let's say, let me go back here. All right, so up here, here, I'm going to actually do this just to keep it in line with what we've just been talking about. So I'm going to have a linked list of integers up here using generics. Actually, this one won't be as convenient. Let me just do it this way. Because we'll still have to extract the int value from it. So let me just do it on, here, we'll just do it with our airports. So we're going to have a linked list of airports. And this guy is going to be a linked list of generic objects. If I don't use this generic syntax here, it will hold everything as generic objects. So let's just assume I've already filled this guy up with airports. So if I say airport A is equal to ll.get at index 0, this will work. Down here, if I say airport B is equal to ll2.get at index 0, this guy actually comes out as a generic object. And I would then have to cast him to airport. I know it's an airport. I put an airport in there. But it gets represented as generic objects because an airport is an object. So it generically represents them. So since this guy was not implemented using generics, when I ask LL2 to get me the value at its index,
it's the superclass.
That's all he knows about. Because if I'm storing it as objects, I can throw anything that's an object in there. I can throw integers, I can throw strings, I can throw doubles, I can throw airports. I mean, I can just put a hodgepodge of crap in there.
So you can have, all the indices can have different objects.
100%, because they're all objects. Every one of them is an object at some distant relative level.
Do people actually code like that?
Oh, sure. In fact, that would have been the old way of coding before really, the reason generics exist is for the convenience of, I get what you're asking. It's probably not common. Unless you needed to hold 2 different types. And let me kind of show you about that. But really, generics is about convenience. Up here, I was able to just say, give me the value at bucket 0. That guy is an airport because I specified this being a collection of airports.
Yeah. So my question was actually different originally because I was trying to implement my own single linked list class. And so I was trying to figure out what should I have it accept. And some people were like, oh, you can have it taken an object. And other people were like, have it taken generics. Because that way you could pass in primitives to it. And, you could instantiate. You could basically...
Well, an object, you could pass primitives into it.
Yeah, I know. We covered that. But I mean, that was just the stack exchange stuff. And I was wondering, what's the difference?
But here, you just asked the question about whether or not people would ever program this way. Let me give you an example of where they would, just to fill in some more logic gaps here. So we might have a linked list. Now, I'm actually going to do this as a generic. So I'm going to say linked list LL. I'm going to say linked list of automobile. I'll just call it auto, so it's short. So let's say I have a linked list called LL, and it's capable of holding autos. But let's say that I actually have a hierarchy here where I have an auto, but then I have car, truck, motorcycle. All three of those classes are actually autos. So because I built this linked list here to hold the generic auto, it can hold things that are cars, trucks, or motorcycles. That make sense? If I made it to hold, I'll just force it to say the object, the generic object, even though that's the default. If I don't use generics and I just say this, it's the equivalent. I get a linked list that can hold the most simple object type that there is, which is object. Now I know the way I had it before, whenever I get a value from this guy, if I say ll.getAtIndex 0, I'm getting an instance of an auto. But I don't necessarily know if it's a car, a truck, or a motorcycle. I just know that it is an auto. Because car, when I wrote these, this guy would have extends auto. Truck, extends auto. Motorcycle, extends auto. So these guys are all children of this top level auto class. And this is a linked list of autos. So if I have 5,000 autos in there, it's going to be a mix and match of cars, trucks, and motorcycles. So now I might say something like auto A is equal to whatever is at bucket 0. But now I can start asking questions. I can say if. So what if I want to know if A is a car or a truck or a motorcycle? Yeah, I want to be able to ask that question.
You just put the cast inside of the statement and that would evaluate true or false.
Is that like an is thing?
Sort of. Actually, there's probably a language where there is an is a thing. I think it's actually Swift. Swift has an is a keyword. There is a Boolean operator called instance of.
Okay.
All lowercase like that. So you would do something like a instance of car. And this would be true if A was an instance of a car.
But if A instance of car, then logical.
Correct. Yep.
Okay.
Yeah. So it builds Boolean expressions. So we'll say var instance of type returns true if var is an instance of type. Something like that. All right. That's why yours was not done? That's what this whole...
Absolutely.
Now,
Now I don't want to be.
this was actually really good stuff, what we just talked about. So, I mean, it got us off on a pretty good tangent. This is kind of, I would call it, not basic programming, but this is fundamentals of programming type stuff, but really, really important stuff. I mean, because if you don't understand this fundamental stuff, then anything built on top of it is like building a house on top of quicksand.
Jordan wanted to know why I could work in IT with the humanities degree. I just proved you can't because I've been learning about this for the past 7 years. I'm like, oh, this is interesting.
But I think I've mentioned this before. I think if you polled 10 professional developers and wanted them to explain this, I think you'd have 0 or 1 that could explain it. It could be, and it really comes down to how people learn to program. Younger people today, they learned how to program with these power tools, and they never bothered to go and learn how things actually work under the hood. They were never forced. Well, I mean, there's some truth to it. And then every now and then, I mean, you might be able to get by 95% of the time. And then there's going to be some weird problem that's going to require that you have some knowledge.
Like, what is it gonna do?
Huh?
Like, what is it gonna
Well, yeah, whatever. I mean, but I mean, I think it's a true statement.
I went to a really good high school though, and so I mean, in high school I took 4 years of programming, and I was good friends with iostream.h, which is I think they use that in C++.
Well, actually, that is the IO.
Is it still
Yeah,
around?
C out and CN. That's the IO standard for it.
Compiler and DOS, man. That's what I was learning on.
So what you're really saying is you don't actually have an excuse.
Yeah, you gotta penalize me. True enough. No, I mean it wasn't. I don't recall it being quite like this in C++.
It's all the same. Yeah.
Yeah.
But that's kind of the thing. So I mean, first of all, I don't expect you. I kind of go overboard giving you all this like backstory stuff to the stuff because every now and then, and the thing is, it might be like winning the lottery. There might be some problem you run into in your life where you're the only one in the office that can solve it. Just because it's based in some obscure language rule that just was passed on since 1968 that nobody else has heard of because they all were born in 2003. You know, something like that. And they
second-year university.
Well, whatever. But the point is that they learned programming with these power tools, and like I said, 95% of the time, that's probably enough. You could be a great applied programmer not knowing everything that's happening under the hood. You can probably think about like mechanics. I'm sure you go to some dealership and, inside the dealership for a car dealership, there's probably 10 mechanics, let's say. And let's say 9 of them, they're pretty good mechanics, but they kind of know what they learned, maybe in tech school or something like that. But you got this one guy that's been like working on cars with his dad since he was old enough to hold a wrench. Right, and they were like building old cars. He like rehabbed some Model T or something like that. So he knows something about car mechanics that just people don't do anymore. It's not taught anymore. It's been lost with the ages, right? So I think it's that type of thing. So that's the mechanic that when somebody comes in with a really, really strange car problem, they have him work on it because like, well, Fred's going to be able to figure this out because I don't even know what I'm looking at here. It's some foreign automaker that, it's got, the Cyrillic symbols. You can't even pronounce the name of the car.
I watched, there's a guy called Doug Crockford. He like invented JSON, and he gives lectures on JavaScript.
Okay.
He's famous for it.
Yeah.
And he talks about the history of programming, and he starts with Lovelace, literally with Lovelace,
Yeah.
and then goes forward. And he talks about how it's all related. Like, decisions they made in Pascal still affect like the modern languages.
100%.
So like it is true. He makes a really good case of like.
So you believe him and not me? That's what I'm hearing from you.
Yes, Doug Crockford is awesome.
How old is this guy?
Crockford's got to be in his 60s.
Okay, so he's older than me. So he learned it before me probably.
Yeah, I mean Crockford was like you weren't old enough to do punch cards, were you?
I did punch cards.
Yeah.
I started programming when I was 9.
Wow. Okay. But I mean, when he was at USC, like they were like take your punch
Yeah.
server time.
Bring in the stack. You get 1 run per day type thing. Yeah, I was past that, but it was still something I could do. Like I lived in Champaign, Illinois, near National Center for Supercomputing Applications. So I would go down to the computer lab my mom would drop me off at the computer lab as a 9-year-old, and I would go in there. And I had like my little bucket of like floppy disks so I could install my compilers and stuff like that on these machines. So I go in, and this is where they invented Mosaic, which was the first web browser. So I knew those guys. Yeah, so I knew those guys. I was like, the geeky kid that was hanging out. Like that's what I thought was cool, hanging out with the lab monitor guys.
Did Brendan Knight come from there? The guy who invented JavaScript?
I don't know. I'm not sure.
Okay. Because didn't they all form Netscape?
Yeah, that group became Netscape Navigator, yeah.
See, Crockford, so that's cool.
Which then became Mozilla years later, which then became Firefox. It's like stock splitting. But yeah, so I was the cool 9-year-old that sat there and watched the world change as the internet was born. And the reason I went to the computer lab is that's where the internet lived. Because this was before, this was in the very, very, very early days of dial-up where basically you only had access to like bulletin board systems. And so if I wanted to have access to like the internet, you had to go down to the University of Illinois to NCSA, and that's the lab. And you had to be a student there and stuff like that to get in, and you actually had to be part of the supercomputing group. Like your teacher had to add you to the thing, but my mom's this old Jewish lady just walks up with her 9-year-old, says, "You let my boy in." So I was like a roadie. Yeah. So now you know what's wrong with me. Is what I'm getting at. That's why I tell people they were out. Everybody was out playing with their friends and stuff like that. I was writing video games when I was. Yeah, I was. This is actually brought up a really funny thought in my mind was we were driving down we were on some road trip, some family road trip. I was a little older than that. It must have been like 10 or 11, something like that. But my mom had got me this, my dad tried to talk her out of it, but got me this little like handheld computer thing that was equivalent to like it had a little programming language associated with, kind of like a graphing calculator type thing. So I was learning how to program this, but when you're first starting, you kind of just type, they had a book that had programs in it. You type them in and see how they work and then start changing stuff to understand why they work, right? So there was this thing, and I think the thing was called Psion, Psion, like mini computer or something. Well, so I type in this thing and it ends up doing like all these like loud beeping sounds. Like it's like, and so it's like really, really annoying sounds. So like freaks my dad out, right? But you think when you get freaked out, you turn around and like yell. Like he's swerving all over the road like a crazy person. Like, Michael, turn that off. That's pretty funny.
How old were you?
Must have been 10 or 11, something like that. Because it was, I mean, I don't think it was my first year programming, but I was young. So.
Now what does your dad think of your programming?
I think it's pretty good. Kind of likes the fact that he's got a son in his early 40s that basically doesn't have to work. Actually, he asked me why I do work. I'd be bored if I didn't. Plus, I wouldn't have anybody to yell at.
What about Mr. Gonzalez?
You think I'm kidding? I have full conversations with Mr. Gonzalez in my house. My wife.
So don't you yell at him?
He yells at me. He's mean. You think I'm kidding? I am not kidding.
I didn't think that, but why can't you yell at him?
I can, but you get less reaction from him. He's very obstinate. All right. So, are we ready to do the homework? All right. Having said that, what was the homework? All right. So, what did we do? We stored our itinerary as a stack, right? And we have that inside of, this is us? Here's my itinerary stack. And what is an itinerary stack? Oh yeah, we built our own stacks. That's fun. Yeah. No, come on. So it's just a stack of strings. That's all that guy is. Oh, so it was easy. All right, so I'm gonna go ahead just as a quick. So we have this this display function. I'm gonna write a public linked list of string function called getAsList. So I can kind of export my stack as a linked list real quick so I can use it inside of my array adapter. Makes reasonable enough sense. All right, so I'll go ahead and create a new linked list of strings. So I have an empty linked list. Now I want to go through my entire stack and add it to my linked list. Now I'm actually going to walk my stack from the beginning to the end because that actually is what the linked list is, right? Rather than doing pops and peaks. This is just convenience because ultimately, if I'm going to have a screen that's going to have a list view that's based on an array adapter, I'm going to need a linked list of strings.
Yeah, and that's what I ended up doing.
I did that too. I felt like it was cheating, but.
Well, I mean, the alternative is we can build our own array adapter to understand our stack, which is fine. Well, I mean, we don't really gain anything from this case, given our stack is just a collection of strings. If we really were doing something more complicated in there, storing some kind of very specialized object that wasn't a string, there's probably some value in creating a custom array adapter. I don't know that it'd be that much harder. We just a little more code. We'd have to just build a custom array adapter. What was I doing?
You were going to make a linked list.
I already made my linked list. Ha! All right, so
So now you just reverse your stack and add
yeah, so I need my itinerary. I don't need to reverse my stack. My stack's actually my stack is stored
You can use
in
the
backwards
linked
order.
list method and say add first each time. That's what I did.
Yeah.
So
That's what I'm gonna do. So
Okay.
what?
Okay, I should what I did. So I put that linked list in core
Okay, why?
because then whenever we were adding to the stack, I also just added to the linked list.
When you remove from the stack, did you also remove from the linked list?
No.
So
That's one line of code. I can add that.
well, okay, fine. But so remember, every single time we hit the back button, we overrode the back button last time, the on back pressed to pop from the stack.
I ran into that because I put mine in core, so I just threw a line in there to clear out the linked list. Do linked list, not clear.
Yeah. I mean, if you wanted to approach it the way you approached it, your better bet would have been to probably build it along with your pushes and pops. In the stack itself. So that's effectively what I'm doing. I'm asking the stack, give me the linked list version of yourself. That's effectively what I'm doing here, but it's fine. I mean, I'm not sure that your solution is like horrific. It's fine. I mean, it solves the problem, right? But it probably starts crossing a line where you're putting too much stuff up on the singleton, but whatever. As long as you document your stuff, it's fine. Life goes on. Okay, so I'm going to go ahead through here and so now I could actually do this with pushes and pops if I really wanted to. I could pop from my stack, push it onto another one, but so I could pop it into a variable, add it to the front of my linked list, push it onto another stack, and then when I was done, I could pop from that stack and back into the original, and now I have the original again. So I actually pull stuff off our stack into a variable, add it to my linked list, push it onto this stack, and then copy that stack back over. But that's pretty destructive to do something that's not all that big of a deal. So what's this thing, an itinerary node? Itinerary stack node. Let's call this guy cur node, and it's going to be equal this dot top. And then we'll say, do I have a count in here? Woot. Well, I'll just do it. I'll do it as a while loop. I'm feeling while loopy right now. Loopy. Cur node not equal to null. I hate that it does that. I want it like that. I'll go ahead and say ll.add front. Add first. It's a weird variable name, a weird function name. Oh, whatever. Cur node.get payload, which is a string. And then I'll say cur node is equal to cur node.get next node. So that should walk down my stack without removing anything from my stack, adding each element to the front of a linked list, because my stack is actually storing my itinerary in reverse. So I'm always going to add each thing to the front of my linked list. So I'm building my linked list as the reverse version of my stack, which is actually the correct order of my itinerary. My stack was my itinerary backwards.
So you're doing this in order to print it to the screen?
In order to populate a list view.
Oh,
So this is for an array
okay.
adapter.
I got you.
Yeah.
Okay.
So I'll return LL here. So this is my ability to ask my itinerary stack to give me a linked list version of himself that I can use for an array adapter for a list view. Okay.
Just to print it out, you could just use a single string variable, right? You could just add the entire itinerary to it and then print it.
Yeah. And we did that last time. It was just reverse,
right?
But yeah, if we just wanted to print it, I'm just kind of setting it up because for the homework, we're supposed to have a string or a screen that has like a linked list of your current itinerary. Think so?
I think you just.
I don't know.
Did you say linked list or did?
Oh, you can do it however you want. I don't care. Yeah, this list of your flights in your current itinerary.
Right. So we could have just added it to a single
That's
string
fine.
variable.
Yeah. I don't care how you did it. I'm doing it as a list view. I guess just because I kind of advertised this assignment as being nothing new, but instead proof that you learned something from two previous assignments. One was the screen scraping assignment, and the other one where we took in just an airport code. Now we're taking an airport code and a month or start and end date, whatever it is. And then also we've done several things with list views now. So now this is just a normal plain Jane list view. But if you just did it as a string and displayed it as a text view, that's fine, whatever. Okay, so I need my itinerary screen. This guy, did I already make one of those?
No, not yet. No.
Okay. So I'll say new activity, empty activity, and we're going to call this what? Itinerary activity. Spell it right? Does itinerary have 1 or 5 ends? Yeah. Okay. So I got this guy. Let's just get us over to this screen real quick. Oh, remember this? I figured out was it in here? I figured out this last week that I can convert my view.
No.
Oh, it's so good. New awesome magic trick. You know how I hate constraint layouts?
Yeah.
So this is a brand new thing that has a built-in constraint layout. Watch this. Just right-click on the constraint layout, and you say, I want to convert that view. Change it to a linear layout. Boom. Now, by default, it's horizontal, so I'm going to go ahead and make it. Actually, it says horizontal there, even though the orientation is none, so I'm just going to make it vertical. So now my top level is a vertical linear layout, which is the exact same thing I initially just throw into my constraint layout so I don't have to deal with constraints.
So how long has this been a thing?
It doesn't matter. I mean, it's just more of a convenience thing.
How long has it been teaching this class?
Well, but they add new things to Android Studio every 5 minutes.
Okay.
Yeah.
I was wondering how long has this been a thing?
I would be surprised if it's been around for that long. I would have stumbled onto it before then.
Right.
All right. So just for right now, just so we can get ourselves here, I'll just throw something up here that just says itinerary. My itinerary. My itinerary. Boom. Okay. So let's just get us to the screen. So I need to add a button. Where's my button going to go? Let me just run this app real quick so I can figure out what it currently looks like. I have 8 minutes left to finish this app. We wasted so much time on that other stuff. Go turbo mode again. What's this?
I'm just kidding. She said but I'm like,
What's this?
He's nothing.
Facial hair right now, it's gonna be like gray hair in like a year or so.
It's not bad. It's funny actually.
Yeah, what was? Am I outside of a joke? I want to hear the joke.
Oh, it's not funny.
She's embarrassed now.
Oh, did she make fun of me?
Oh,
No.
I just said a bad joke. It made everybody confused. No, it wasn't.
They can't be on recording. Is that the thing?
No.
You're making fun of my oldness.
No, I'm laughing at Ani.
She was making fun of my oldness. I heard kids was like calling me a child.
Well, we already decided that you had all the background you needed to answer all those questions yourself.
Good for you, better staff.
just calling balls and strikes up here. All right, what am I doing? So we're going to airport list. I'm gonna pick some airports. So start at Milwaukee, and I'll go to Atlanta. It's in there already, right? Yeah. And then we really should have a search on this screen, but whatever. We got Albany in there? Oh, we don't. All right. Well, no, I do already have a button called View Itinerary.
Yeah, but you have a button. You don't have a screen.
Oh, I have a screen now.
Yeah, so you just have to hook it up. Yeah. You just need to hook it up.
I'm already raging today.
Yeah. What was the word coffee? Goodness. You said it was the coffee.
But did she spike my coffee? This is a dry campus, people. What am I looking for? What screen is this? This is called. I'm gonna start organizing this. Next break, we're gonna organize this into some group things. What's it? Detail? List? You lying? I think you might be. Okay, it's not that one. So I think it's airport detail activity. Just have a show display itinerary. This guy. So we need him to go to the new screen. So we'll say intent I is equal to new intent, and we're gonna go. We need to go from this context, right? And then what are we going to? What do I call it? Itinerary activity. Itinerary activity.class. Oh yeah. Okay, so this dot start activity. Let's make sure that gets us there. Can't see anymore. Everything's all blurry. All right, go to Atlanta, then we'll go to, what did I do? What did I click on? What did I click on before? Albany? Oh man, you can only go back to Atlanta from Albany? That's a crappy destination. I had an uncle that lived there. And he moved to California, lived down the street from Jose Canseco when he beat up his wife or something. Back in the years. Remember Jose Canseco? Oakland A's baseball player?
Yeah. Yeah, he just came back in the news recently.
What is his domestic abuse?
No, he was,
Dancing with the Stars, probably?
A-Rod and J-Lo got engaged and he was trying to bring her up.
Oh, I see.
He got his, like, 15 minutes of fame.
Yeah, Jose Canseco was like the original Major League Baseball steroid guy, wasn't he? Yeah. And you had all the other, Mark McGwire, Barry Bonds, they all copied him. Sammy Sosa. I don't even know how anybody believes Sammy Sosa wasn't on something. Did you see Sammy Sosa when he was like early in his Cubs career? Guy was a toothpick. Later on, he was 5'10", 730 pounds of sheet muscle. All right. So I'm going to say view itinerary should take me to my new extreme, and that's spelled correctly, I think. All right, so we're going to put a list view on this guy. We're going to grab our linked list, and we're going to get our array adapter. So, and then we'll be done with first part of the assignment, right? So this is my itinerary. Where's my legacy? Here's my list view. We'll call this guy itinerary LV for list view. And then we'll, okay, hold on. I need to close a bunch of this stuff. So I'm going to do this. Close all. Then I'm going to open up itinerary activity. I'll go ahead and give myself my itinerary stack. And then, you know what would be awesome is, where's my itinerary activity? It'd be really good if I could open this file by highlighting it. Let's click and test. No. That'd be really good though. That way I didn't have to go and hunt for it. So r.layout.activity itinerary. Oh, it did show up in green there though when I had it highlighted. It was kind of handy, I think. All right. So I need to give myself access to this list view. So that's in this guy. So I'll say list view itinerary LV is equal to this dot find view by ID r.id.itinerary list view or LV whatever. Then I'm going to need an array adapter. And this guy is going to be of type string, and we're going to call this AA. We don't need it to be any more global than this because at this point we're not passing this around. It's just a one and done. Here's your list of stuff. But before I can, well, actually this is fine. So array adapter AA, this is going to be a new equals a new array adapter of type string. And array adapters take in what a context. And then an r.layout dot was another row, the simple one, or did I create like a simple one? Yeah, I think it was another row. This was a very simple one. And then we're going to have our core dot current itinerary stack dot get a list, get as list. And then itinerary list view dot set adapter to AA. That should be it. All right, so we'll do airport list. We'll filter on Milwaukee. Click on Milwaukee. Click on Atlanta, click on Albany, view itinerary, and there's Milwaukee, Atlanta, Albany. All right, so that's that part of the app. All right, and the other part of the app was pick a date, right? View direct flights from starting from a date. Oh, month, that's right, yeah. So, what did I say in here? All right. So let me go ahead and create this screen real quick, and then we'll take like a 45-second break, and then we'll come back and just write that code real quick. So it's not going to take that long, but let's just, unless you want to take a 5-minute break right now before I do that? Sure. 5 minutes, no more than 5. Anybody who wants to go around and like stretch or something, you can always do that. But officially, no. Let's do 5 minutes right now. That way I can upload the hour video.